click. All right, we are recording. This is take-home test 2B part 2. It's fall 2022. Here we go. We're gonna be efficient tonight. I'll tell you what, I'll move kind of quick, and then at the end, if we have time, we will talk more about, we can go back to problems, and doesn't mean you can't stop me or chat and ask questions and type it in there if you want. I got to get through these. I'll make this kind of like acts like a key as well. I want you to have the right answers going into tomorrow. All right, so I'll do the same thing I've been doing, and I will talk about a little bit and make a few chicken scratches here and there, and then we'll go to the answer in each one of these. Okay. All right. So the first one, 14, is a good problem. That's it. You know that it's all these are going to be trios. I'm not going to throw a quartet on you. I may do that in packet 3, but not here. So all of these are going to be trios, and I've already walked around the room and seen that most of you have done this. So you know that acceleration is going to be constant, and it looks like it's pointing to 4 the whole time. So 4 meters per second squared. I can take a ruler and get the next ones on this. And you don't want to test, you're always kind of in a hurry, so you're a little bit pressed for time. So this is fine with me. I'm okay with you doing this. Hold on. Okay, I'm okay with you doing this, connecting tips like that. Just slap, as long as you go ahead then and draw the arrows. You would get some points for that, but you're not gonna get full credit unless you actually draw the vectors. Okay, and you put the right direction. Because that's really what this is. It's a combination of vectors and a trio. So I guess call it dynamic vectors or something. Can you guys hear me okay? Thumbs up, hear me? Can you hear me? Yeah, okay. And then this is the one. Okay, so and then obviously this is going to be the equation, the first orange, which is going to be V naught plus AT. Well, V naught it shows as -8, and you got to put units on these numbers. You can't just leave it as -8. And what is yeah, meters. -8 meters per second plus A, which is +4. Always check to see if it's positive or negative. +4 meters per second squared times T. Okay. Over here, you're going to have X naught in the first slot, and that's easy to read that off the graph. 20 meters. You're going to have V naught T in the second slot, and you're going to have 1/2 AT squared in the third slot. So we already know the equation. That's going to be -8 times T. I'm kind of keeping one eye on your comments in case you want to stop me. And you can always, if I'm not paying attention to your comments, just turn on your mic and jump in there. Cole was always good about that. And then we have 2, because 1/2 times 4 is 2. 2. I would have counted off on myself. Meters per second squared times T squared, and this should be -8 meters per second. Okay. This guy is a positive trio. So I know it's not going to do this. No, it's not going to do that because it's a positive trio. So it's going to open the other way, and it's going to go whoop, something like this. Whoop. Okay. Now it's a matter of plugging and chugging and into this equation. Plug 1 in, plug 2 in, plug 3 in. Okay. Let's skip to the answer because I'm worried about time. Here is the answer to that. The key, the official key. Okay. I'll leave it up there for a second. Anybody got a question? Oh, Ashargo says, does the equation need to be in the proper order? For example, that's a good question. I don't care on these blanks. I don't care what order you put them in. It doesn't matter. Okay. For calculus and for algebra, the standard order is to always put the highest power first, right? This is considered, see my arrow there. This is considered a second order equation. So in algebra or in calculus, you would put that T squared first, and then you'd put the T, then you put the 20 meters at the end. It's historical, I guess, but for some reason in physics, they do it the other way. But I've seen it both ways, so I don't care. I'm doing it kind of like it is on the hanging from the ceiling, you know, the way the orange equations are. But I really don't have a preference there. All right, let's go on to number 15, I mean. Now, I have no idea whether I was having a little mini stroke when I wrote this. I don't know what was going on, but this problem is wacko. I mean, it works. It's not, I can't say it's wrong. Ugh, if I can draw straight lines. You should be using, I'm getting shaky hands here. So A is equal to -6. I think I started off with one thing and then didn't switch it. I don't know. It's a mess. So I'm dropping 6 each time. So if I start at 9, then I'll end it, then I'll be at 3, and this is by 3s. The next one I'll be at -3. Okay, so I have enough now where I can connect up and all of a sudden my heart sank when I was doing this, when I realized, oh my gosh, it's going off the graph. Sure enough, it is. So I just went with it and went down. It won't happen on the test. Okay. I've vetted this. I've already written this question and vetted. It's not going to do this. What a mess. Yeah. So then you draw your arrows. Okay. And you see, so then your equation, you're going to have V equals 9. V naught is 9. Just reading it off the graph, meters per second times T. So look at this, Sargo. Here I'm doing it the other way. It doesn't matter. I can read it either way. Plus V. Oh, no. Getting all worked up. That's V naught plus AT minus plus -6 meters per second squared times T. Okay, I did do it the same way I normally do it. Over here, here you go. Once again, X naught is 16 meters. Look, judge it from that. And then V naught we said was 9. So we have 9 meters per second times T, and then 1/2 A. A is -6. So -3 T 3 meters per second. Meters per second squared. I'm trying not to get tic-tac with little tiny -2, -3s. T squared. Okay, then it's a matter of plug and chug, and this thing goes totally off the graph. Yeah. Yes, Sharga. I don't. The order doesn't matter that you put it in. All right, so this one is a negative. See, it's a negative acceleration, means the bowl points down. So I should expect, and then right here is going to be my apex, right? In this case, it's apex because it's pointing down, or it's an upside down bowl. So I'm already realizing that I screwed up here because I'm right there. I'm going to have to be somewhere up in here. So I know it's going to look something like, that's about 1.5. It's going to come down like this, what I was thinking, but it doesn't. Let's skip to the answer. That's what I got. And when I went around the room, I saw a lot of you had the same thing. So apologies. I guess that's not a criminal, not a horrible thing for me to do on a take-home test, but that would be criminal for me to do that. I might get arrested if I did that on a in-class test, because that would be, I would punch myself in the face, because that would be very disturbing. So it'll be, in other words, the graph will fit the equation on the test. So I apologize for that. Okay, I'm going to keep going. Thumbs up. Where's Finn? Oh, Finn, man, you're missing your cue. Finn's always the first one with a thumbs up. All right, let's keep going. Number 16. I did see some mistakes on this one. You're going to color it in, and Davey's always got to get every little time. Look, this is cool, Dave. Just do this. I'm cool with that, especially on a test. Who has time to go through and get everything just perfect? You're not, as long as you're in the right area. This is where students messed up, is they were on that perfect bow tie. They were coloring in the wrong parts. But remember, this is a stalactite. This is a stalactite with an angle. This is a stalagmite. They all grow from this 0 point. They all grow from the 0, up or down. Think about it that way. Okay, so this part is a duet. We did this in class. We did one just like we did the opposite of this in class. But this part here is a duet, purple. This part is a duet. And this part over here is a trio. Okay, trio, duet. So we know this is going to be linear. It's going to be negative because it's, negative slope. So something like, I'm going to show you the key here in a second, but something like, let's go big here, something like this, okay, something along those lines, all right? And then this, and I'm going to the key, I'm just giving general ideas. And then this starts off with the same slope as it was at the lowest point on that line. It still has that slope, but now the slope gets closer and closer to zero. So wherever we're at, we are flat here. The tangent line is flat. So this is going to come down now, come down and kind of curve. This is girl in the Jeep stuff, kind of curl in, and then it's going to be symmetrical because it's a bow tie. Those are congruent. It's going to now curl back up. So it'll look something along those lines. Okay. Let's go to the actual answer though. Oh, let's blow this up here. Okay. There's the answer. Duet and trio. Duet and trio. About what I said. This is more, accurate though. Okay, we're doing good. We still got 25 minutes. We're fine. Questions on this? Sort of a preview, really, of packet 3. Girl in the Jeep day is coming. Anyway, so, but you all did pretty well. Let's keep going. Now we get to one like this, and this always bothers students. Last year, this was a rough problem. I think I went back and looked at it. I think it was black. One like this. Well, let's take a look here. But you've had a little more practice than they did. So a couple questions students have asked me on this. They said, if it's like nothing, no arrow on it, how do I know if it's 0 or if it just hasn't been done yet? And you have to look at, like in this case, I look at this V and this V, and that's going to dictate the velocity. And I gave you an initial condition. I gave you the initial condition on X, so you'll need that. But the velocity kind of dictates what's going to happen above it and below it. So remember, here, here, the acceleration is the granddaddy, and that's going to kind of tell velocity what to do. Velocity in turn tells position what to do. Okay. So you can do it, you can go either way. Acceleration is easier because it's constant. Okay. So I'm just going to look and say, well, what did acceleration tell velocity to do? Well, it told it to, what velocity was at 1, 2, 3, 4, then it was at 1, 2, 3. So acceleration tells velocity to lose 1, not gain 1, to lose 1. So velocity every time, acceleration every time is back. Boom. Every time, it's constant. These are trios. It will not be a quartet. It's a trio. So acceleration is a -1 because that's what it's telling. So now since I know that, I can go ahead and finish my velocity row. If that's the case, then this must have been pointing to 5. I'll go orange here. This must have been pointing to 5. 1, 2, 3, 4, 5. That was 4. That was 3. That's 2. That's 1. Okay, so the velocity never turns around. Okay, now to get this top row, I don't think, maybe there's some fancy way of doing it, but I'm pretty sure the only way to make sure you're right here is to go with the old graphical version. X equals X naught plus V naught T plus 1/2 AT squared. Because of that daggone parabola, you can't just kind of wing it in there, The thing starts off at a negative position, 1, 2, 3, 4, -5. So I know that X naught is -5. At time equals 0, but then I plug in my V naught. V naught is not 4. V naught is 1, 2, 3, 4, 5. V naught is 5. I guess these are meters, I suppose. Somewhere it says. If not, then I'm going to assume meters per second. That's meters. And then acceleration we know is -1. And then it's just plug and chug. And let's go to the answer. Okay, there's my work on that. And yeah, it looks like I plugged and chugged to get it. But I'm looking at this and I'm thinking, is there a way to do that without having to plug and chug? Like, is there a pattern? It's really hard to pick a pattern on this because obviously velocity is dropping 1. Okay, that's easy. But because there's two things involved in the position, there's both, you get a direct influence from the velocity vector and you get half the influence from the acceleration vector. So you kind of have to, like, I wouldn't be able to predict, this perfectly just by looking at arrows. So I kind of had to do the equation. Questions on that? I feel better about time now, so I'm not going to rush so much, but questions?
Wait,
Davey, put his mute back on. Okay.
never mind.
Thinking about it. He's got a question. He's thinking about it.
Never mind.
And Davey, you can also type it in too. Okay. I'm gonna keep going. We can come back to it. We can come back to it at the end if we have time. All right, now we get to this one. There's no way I'm going to sit and do all this, but just to show you the general idea, and I'll tell you right now, there's one of these on the test. I wrote that question during Botball Night, so there's one of these on the test. So you got to do your business here with this old guy. When you do it, that's why I tried to show you a couple of examples. I need some glasses. Look, I start seeing doubles, so don't laugh, but I can't find my other glasses. I have these special lenses. So look, that's going to be really tight right there. Okay, so that's probably good enough. I say color it, but we're on a test. We don't have a whole lot of time here. As long as you do it, you show it in some kind of, and then show a different color over here. So that's also orange. Okay. And then I'm doing purple for the negative ones. But notice the negative, as we do, negative slopes are upside down. Over 1, down till I hit the parabola. Oh, hey, I got a shortcut. This came up today. You know what's a real nice shortcut here? Since that is a parabola, then this is a line of symmetry. So you can get away with it. I'm cool with this. Okay. You're just being smart, right? Don't work harder, work smarter. So symmetry. It's okay if you do the left half or the right half and just do a mirror image for the other half. That's going to save you. It's going to cut your time in half because you're going to find, you're going to find this slope. You're going to find that. Oh, that's dividing by 2 now. We're not dividing by 1. So this first one would be like 10 or 9 divided by 2. So something like 4.5, 4.5 for 0 to 2. The next one is just looking at it here. I did my lines way too thick. That looks like 5, 6, 7, 8, maybe 8 divided by 2, maybe 4.0. Okay. But I'm not going to bore you by doing all those. But once you find all those orange triangle slopes, then you put those on this chart, and then just flip it. you know, because whatever this is right here, this like whatever this one is right here, this is just the opposite. Whatever this one is right here, this one's just the opposite because it's symmetry. Big concept in physics is symmetry. So once I start doing my stair steps, you know, I'll do the first one at 4.5. What is it? 2, 4, 6. Okay, the first one goes, and make sure you put those open circles on the end. First one's at 4.5. Next one looks like it's at 4. Okay. And so I got the stair step going down, right? Whatever it is. Then I get down, and I'm not saying this is right. I'm just messing. Let's say that, and then that's almost 0. And then I hit 0 at 12. Yeah. Then I come down purple. I'll give the exact thing in a minute. All right. So but once I have this part here, the other part is just, once I establish the slope with the orange, in my case, orange, that's going to be the same slope as the purple. So it's stupid to waste, 5 minutes doing the purple. Oh, one step I forgot. You're going to have to collapse. I need to see it. I got to see that step collapse down to a dot, because that's where tangent equals, and secant and all that. So once I have that, I can go ahead and just do a best fit line through those, and I'll go right to the answer. So that's my point on symmetry. That'll save you some time. Yeah, so I did everything there. I got 4.5, and then I got 3.5 when I really did it. I was very careful here. But I went ahead and go ahead and humor me and do the other triangles, but I'm okay with you just doing, see, I'm showing, but you got to write the word symmetry. Okay. You got to let me know that, why you can do that. Okay. And this is pretty accurate. I mean, I got the scale out. I can blow this thing up. So this is a pretty good key right here. Now, once you've taken the steps, collapsing down to a dot, and then did a best fit line, and this is generated data, so you should get a really good line. Then the slope of that line is your acceleration, and it looks like my acceleration is around, it's negative. What did I get? I got a slope of -5 divided by 12, so -0.4 somewhere in there. Okay, -0.42 it looks like, and that's flat. Okay, so that's a negative trio. You're going to get examples of a positive trio example on the reference sheet, which, by the way, I put the 2 sheets that you get, color versions of those, in the guide 5 of Facebook, which is a PDF. So if you have a color printer, access to one somewhere, and you want to print out a color copy for the test, you can do that. Otherwise, what I'm going to give you Thursday is a black and white, which is not as good, but I can't afford to make color copies. But I'm going to, and they don't even have a color copier right now, but I'll make like 30 of them, and that'll be a classroom set, so you can't even take it with you. It'll put it in a page protector. Okay. Problems, questions before we move on? So that was number 18. In fact, is that homework tonight? Or was that maybe that was last night. I think that was last night. Okay, now we move on to tonight's homework. Okay. Well, this is right out of your notes. I mean, it's also on the Facebook group from that day. I think there says orange derivation or something in the, you look at that title screen on each one of these to know what's in give you some idea what's in there. Well, I'm not going to sit there and go through each step with you again. This is exactly how, and this will be on there, and this is exactly how it will look. It's a little tight though, but your opening step is crucial. Get that opening step right, and then it kind of comes to you. But your first step is just to use this V bar. I can't see again. Everything goes double. V bar equals delta X over T. That's your first step. Okay, and the reason is given or intro. Remember there's only 4 reasons in this class. It's either intro, ISO, which isolate, sub, or just RE, which means I rearrange, I did some physics, I divided both sides by T, whatever, that's rearrange. Okay, the next step then is delta X equals V bar times T, and you're off to the races. That was a ISO. Okay, so I'm not gonna sit there and do it all again. We did this already in class, and there's also a video on this somewhere, a help video of me just going through all the steps. Anyway, here's the key. You should already have this somewhere. So notice it's intro, ISO, intro sub, RE. And some students memorize that. I hate to say memorizing, but you know, you should do it a few times. Do it once tonight, maybe do it a couple times tomorrow night, do it once Thursday morning before you get in class, and then you probably have it. And some people, what they do is they look at that reason column and they go, okay, that's an intro, ISO, intro sub, RE, make a little song out of it. And they write that down. That kind of helps them remember what to do. I would just assume you not memorize it, but I'm trying to once again pattern you into understanding this is a derivation. It's our first really decent derivation of the year, but pretty much most packets have at least one good derivation in there. All right, let's keep going. Now we're going to use that to work two problems. So I got about 10-12 minutes here. CLDPA, Claudia asked if we'll be given CLDPA. Because she asked that, I went back to that sheet and put CLDPA at the bottom and then put what each one was, you know, circle, label, draw, equation, box in your, but you'll have, here's what you'll have on there. If I have room, you'll have this isolated variable box where you got to put the isolated variable equation in there. Once you isolate what you're trying to find, like in this case, we're trying to find blah, 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 blah. What's the acceleration? So you have to isolate for acceleration symbol wise without the, you know, without the numbers, except for coefficients, and put that in a box, kind of like that problem we did today, where we had to first solve for A and then plug in our numbers. Okay. So we circle and label. This is kind of weird because there's a two, it looks like we're going to use that, the other version of the second orange, which is, you know, X final equals X naught plus V naught T plus 1/2 AT squared, because that's my X naught. And that's my X final. Okay, so X final is 8, X naught is 2. During 2.5 seconds, that's obviously the time. The velocity of the particle at, okay, there's my V naught because it's at 2 meters. So I know my V naught now. I know everything but, oh, and I know my time. I know everything but acceleration. Okay, so what some students did today is they said, okay, at that point, they plugged in their numbers and they did the math, which, okay, I'm not going to, unless there's an isolation box, I'm not going to count off for doing that, because I understand tests, you're kind of in a hurry. But if I remember, I haven't quite finished the test, I remember to squeeze in an isolation box, then you got to be able to show me the equation for acceleration. In other words, solve this for acceleration. Which if I, let's go ahead and do that real quick. If I do it here, I'm going to do, I'd be X final minus X naught. First, I get everything over to the left side, minus V naught T. Okay. Then I'm going to multiply this by 2. I'll multiply everything by 2 because I'm trying to get rid of that 1/2. So I'll multiply this by 2. And then I'm trying to get to the T squared. So to get rid of multiplication, you divide. So I divide that by T squared. So that would be unless I messed up, that would be my, yeah, that's right. Yeah. That would be my isolated variable box. Okay, that would go in the box. All right. So if I have room, I will put that into the problem. And of course, the drawing, you know, you got to, drawings are pretty simple in here. You just put for now, X naught, X final. I know V naught, so I'm gonna put a V naught right there. I know T. I'm being close on time, so I gotta hurry. I know T, and then I'm trying to find A. So that'd be good enough for a drawing. All right, let's get, Rafa says, instead of writing X, yes. Of course, X final minus X naught is just delta X. I'm fine with that. The only reason I wrote it as X final minus X naught is because the way it was. But would I count off for you making, no, I won't count off if you call that delta X. Okay, let's go. Let's cut to the answer. Okay, here's what I did. And there's my box. And notice, Rafa, what I did, I also did delta X, so that's cool. So it shows, see, just looking at the problem, I don't know whether it's slowing down or speeding up. I mean, if you read that problem, it's not obvious if it's slowing down or speeding up. I had to actually do the math and I was surprised when I got the answer that this object's actually slowing down because acceleration is hidden. Acceleration is hidden, right? You can see velocity sort of, you can see the position, but you can't see acceleration. So it's negative. And like I said, very hard to tell unless you actually, okay, I'll blow it up so you can see it on your little tiny phones when you're watching the recording. Because you can't use laptops, sorry. Okay, I'm worried about time. We're gonna keep going. Dylan Gabriel, so here we 20-yard line. All right, so this is a new problem. I just wrote this last week. The 20-yard line does kind of play a role. That is pretty much, that's sort of like your X naught. That really is your X naught. I didn't boldface it, I should have, but oh golly, everything goes double and blurry. That's what, moving at 4 years, so that's my V naught. Straight up field. He's not going in an angle. I don't want to bring in angles yet. That'll be packet 4, more angle stuff. Accelerates, there's my, and you've got these kind of units of yards now, but so what? That's my acceleration, there's my time. And now what yard line? So in other words, what is X final is what we're trying to find. What's X final? So after Christmas, you don't have to do the circle and label. You can just do all of that right there on the drawing. But it's kind of redundant, but I want to get you used to, circling, seeing what the numbers are. I know A, I know X naught. I'm trying to solve for X final. And that's all I know, and I know time. Okay, so that's the stuff I know, the symbols I know. I'm solving for X final, okay? So once again, that's a bit of a, I didn't mean for that to happen, but it looks like it happened again. X naught plus V naught T, you're writing down the CLD, but you're writing down the E, the equation, plus 1/2 AT squared. Okay. Boy, Zoom's going to cut me off for a minute. So it's already isolated. That's good. I can box that in. And then I go, now it's plug and chug time. No unit issues. It's all yards and seconds. Everything's cool. Plug and chug, right? And then that should give you the X final will be the yard line. I'm going to cut to the chase here. You're the first ones to see this, so I hope I did it right. That's how I did it the other night when I made the key up. So 41-yard line, a 21-yard scamper. That's pretty good. They get the crowd going. Okay, questions on now. I don't need, now if we get cut off, I'm not doing another tape. So I'm curious though if I'm going to get cut off. Okay, questions on number 21. Questions? Looking at the chat. Okay, so I think we're ready for overtime. Maybe we only have a few minutes. But overtime means if you just came here for the facts and nothing but the facts, you're free to go. If you want to stick around and ask a question, I'll leave the recording on because last time overtime was the best thing we did. So I'll leave the recording on as long as we can. If we get cut off, we'll just there'll be no warning. We'll just end, but then that's still cool. You'll have I'll put the tape up on YouTube by 10, probably. All right, so I'm saying adios. If you want to stick around, stick around. Okay, so now we're officially overtime. Anybody want to go back and look at one, ask a question, talk about the governor's race? No, we can't do that. It's politics. I'm down to Davey. Davey. Just you and me, kid.
Okay.
You have a question, Davey. Now, here's the good thing, Davey, since it's taped, I know I went too fast, but now you'll be able to, within 30 minutes, go back and watch the tape. And you can watch tape all day tomorrow and, to your heart's content. But I would suggest you watch this tape and part 1, and then you're going to walk into that test very confident.
Okay.
Okay. Any questions, Davey? I'm going to cut you
No.
off.
Bye.
I'll do it.
What?
You're not doodling, are you? Okay.
No.
I'm leaving, Davey.
Bye.
It's just you and me, kid. There he went. Okay. Now I will end it.